So in this video I intend to talk to you about the differentiability of a function. And so just as a definition, when we say that a function is differentiable at x equals c, and by the way, we almost always put an x value with differentiable, like we won't just say that a function is generally differentiable, or if we do it means it'll be differentiable everywhere. But if we say that a function is differentiable at x equals c, it means that the derivative at c exists. It means that f prime of c exists. Right? So when somebody asks, oh, is that function differentiable at a value? They're basically just asking, does the derivative exist? I mean, differentiable could be derivativable, but that sounds dumb, so they decided to go with differentiable instead. Okay? So that begs the question, so what would cause a function to ever not be differentiable at a point? So what are the ways that a function becomes not differentiable? And I would argue that there are effectively three things that you're looking for in a graph. A discontinuity in the graph will always cause the function to not be differentiable. If the graph has a sharp point, which is sometimes called a cusp, the function will not be differentiable there. And the third thing that causes it is vertical tangents. And in my opinion, there are sort of three different reasons that these cause non-differentiability, and I'll sort of cover each of those by looking at a graph or two. So the first case is if a function is discontinuous at a point. So let's say that we have a function that is like this. Or, I mean, even if we had a worse discontinuity, right? If we had something like this. Right? In both of these cases, and I guess what I'm getting at here, like let's say that this is x equals 1 in both cases, right? I would argue that in both of these cases, our function f of x is not differentiable at 1. Is not differentiable. Sorry for my horrible handwriting. At x equals 1. Now why is that? Think about it, what it means to be differentiable. What it means to be differentiable is that the derivative exists, right? So if someone were to say to you, hey, what's the derivative at 1? They're basically saying, hey, what's the slope of the tangent line? But if you think about it, there can't be a tangent line. I can't have a tangent line that comes along and hits this function at only one point. Oh yeah, the point where the function doesn't exist, right? I can't have that happening, right? Similarly, in my other one, if someone was going to try to put a tangent line here, you know, they might have a tangent line here, or wait, maybe down here. Given that the function is discontinuous, there's no way for me to draw a tangent line and then come up with what the slope of that tangent line would be. It makes sense that these functions are not differentiable at 1 because I can't even draw a tangent line on top of them. So the point I'm getting across in this slide is the idea that if a function is ever discontinuous at a point, it means the function is not differentiable there. The second case are sharp points, right? And so one example that you see if something like this is, you know, the very innocent absolute value function. But we'll occasionally have stranger things. You know, occasionally we'll have a function where, you know, you'll have a parabola and then suddenly it'll kind of turn into a line graph. And they're like piecewise functions. But in both of these cases, I'm sort of curious, like at this, you know, value of x being 2, and let's say that this one was also 2, why are these not differentiable at those points? Why would we say that f of x is not differentiable at 2? And a part of it is in this one, if you sort of think about what's the slope of the tangent line here, well, from one side, it's looking like the slope is going to be -1. But from the other side, it looks like the slope is supposed to be +1. The function can't make up its mind whether it's +1 or -1, you know, or maybe some crazier thing in here like this. Neither one of these things none of these values make sense. We can't say what the slope of the tangent line is there, so it makes sense that we can't say that the function is differentiable there. Right? We have exactly the same thing happening over here, right? On the one hand, these slopes are looking, you know, they're sort of turning out to be maybe +1 or so, but then suddenly it changes to this other slope. At that sharp point, the reason that it's sharp is because the slope is suddenly changing, and so we can't say what the slope is there. So your conclusion here is something to the effect of, you know, because both functions have a sharp point or a cusp at x equals 2, we would say that neither function is differentiable at x equals 2. Note, it's differentiable everywhere else. I can take the derivative here, 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 here. Like all of these values that aren't +2, I can take those derivatives. The function is differentiable there. It's just not differentiable at the sharp points. The last case that I have are vertical tangents. And these are somewhat rare, but they happen. Right? So if you have a function, like the most common function is something like, the cube root of x, and I'm going to shift the cube root of x. But the cube root of x basically looks like this. Right at that central point, and I didn't do a very good job of drawing it, but right at that central point, the tangent line is actually vertical. Right? Now it's interesting, in this case I can draw the tangent line. Like there it is, I drew it. But why would we still say that this function is not differentiable at x equals, whatever x value this is? Why would we say that it's not differentiable? And the reason is, think about what the derivative is. Think about what the slope of that tangent line is. The slope of that tangent is undefined. That unfortunately means that the derivative is undefined, which means that the derivative doesn't exist. And that's why if a function has a vertical tangent, it will not be differentiable there, because we can't take the derivative. We can't evaluate the derivative there because the slope will be undefined. So, in summary on this thing, there are three things that cause a function to not be differentiable. A discontinuity will always do it, a sharp point will always do it, and a vertical tangent will always do it. If you have any of those three things happening, your function will not be differentiable there. Anywhere else, it's fine, and it's differentiable.